Hi, this is Mrs. Kidman, and in this video, we're going to be going over polynomial long division. Now, before we can do polynomial long division, let's just review long division itself. So we typically call it long division because what happens is we have something like this situation where we have a number that we're dividing by another one, and we don't know exactly what it's going to be off the top of our head. It's not one of those times tables that we've learned. And so what we're going to do is we're going to go through that long process instead of typing it into our calculator to figure out what it is. And so oftentimes we'll see a problem presented like this one, 723 divided by 25. And so what we do is we actually have two pieces here when we're looking at that. We have our first number, which we call the dividend, and that dividend is the piece that we're dividing up. And then the 25 is our divisor. So this is how we're dividing it up. And what we're going to do is we're going to set it up in a little box here where we put the divisor on the outside and the dividend on the inside. And then what we're going to do is we're going to divide it. So first what I want to do is look at the first number here, or the hundredths place. Does 25 go into 7? If it doesn't, then I'm going to skip that place up above and go to the next one. Now does 25 go into 72? The answer is yes. I know that 25 goes into 72 at least once. So what we're going to do is write down how many times does it go in. Well, 25 times 1 is 25, 25 times 2 is 50, and 25 times 3 is 75. Well, 75 is more than 72, so it's not going to be 3, so that means we have a 2 here. So what I'm going to do, once I put this 2, notice how it's up above that number, that like tens place. We're going to do 25 times 2, which is 50. Now, once I have that 50 down below, what I'm going to do is subtract it, and I'm going to do a subtraction problem. So 2 minus 0 is 2, and 7 minus 5 is 2. And then what we're going to do is we're going to bring down our next number, and then use that to then continue on. So then we have 225. Well, 225 and 25 actually go into each other pretty well. So 25 times 4 is 100, times 8 would be 200. So that means times 9 should be 225. So I'm going to put that 9 here. 5 times 9 is 45. Put my 4 here. 2 times 9 is 18, plus 4 is 22. And so what we end up getting here is that 273 divided by 25 is 29. And this 29 here is going to be our quotient, is the name of that. Now, sometimes numbers divide perfectly like this one, but sometimes we have a situation like this one where the number doesn't divide perfectly. So let's go through that long division here with this one. So 7 doesn't go into 3, but it does go into 36, and it goes in 5 times because 7 times 5 is 35. Then we'll subtract those. 6 minus 5 is 1. 3 minus 3 is 0. And then I'm going to bring this 5 down. How many times does 7 go into 15? Well, it goes in twice because 7 times 2 is 14. And then we subtract and we get 1. Now notice how there's no other number here. So in the past, what we've done is we've added a decimal place up here and dropped down a 0 and continued on until we get a remainder of 0. However, in this case, what we're going to do is we are actually going to talk about this number right here as being the remainder. So the remainder is what's left over that doesn't divide back in. Now that remainder is going to be super important when it comes to long division with polynomials, because we actually write a fraction with a base that's going to be a polynomial with whatever remainder is left over. Now with that, we do have a couple of special conditions. So if I have a polynomial, f of x, and I'm dividing it by a divisor polynomial, then what I'm going to get is a quotient polynomial, which is whatever's up here, like this is our quotient, plus our remainder divided by our divisor. Okay, and so the biggest thing to be aware of is that our remainder needs to be less than our divisor, the degree of them, and the degree of the divisor needs to be less than the degree of our original function. Because if it isn't, then it won't work. So let's take a look at this first one here. What we're going to do is we're actually going to set it up exactly like we would set up a regular division problem. Put the dividend inside, x squared plus 3x minus 15, and put this piece outside, our divisor outside. Now what I'm going to do is I'm just going to look at this first term here. Now I've got an x and an x squared. So I need to ask myself, what number times x gives me x squared? And the answer to that is x. And so what I want to do is I actually want to put an x up there and multiply them. X times x is x squared. X times negative 3 is negative 3x. And then what we're going to do is we are going to subtract those things. Now, one thing that really helps me when I'm subtracting is I actually will change my signs. So this one is a minus sign. This one turns into a plus. just so that I can see, and then I can add those numbers straight down. So x squared plus negative x squared is 0. Positive 3x plus 3x is 6x, and then we're going to bring down our minus 15, just like we were before. Now I need to ask myself, what number do I multiply x by to get 6x? Well, that number is going to be a 6, right? A positive 6. So we're going to write plus 6 there. X times 6 equals 6x. Negative 3 times 6 is going to be negative 18. And then we are going to change those signs. So this one becomes a minus, this one becomes a plus. 6 minus 6 is 6x minus 6x is 0. 15 plus 18 is going to give us a positive 3. Now notice how I cannot multiply any number x times some number to get 3. So this right here is going to be our remainder. And what we're going to do with our remainder is we're going to put it over this fraction here. So when we talk about what this equals over here, what it equals is this part on top. So x plus 6 plus our remainder divided by our divisor. Okay, so that's how we're going to do that polynomial long division. We're going to set up our dividend inside, our divisor outside, and ask ourselves, in the first term of our divisor, what number does it have to be multiplied by to get that first term in our dividend part that we're looking at? And then we're going to put that right above that piece. And then we're going to go to the next piece and add it and add it and add it until we get those values. So let's go ahead and do 2 more examples. Let's take a look at this one. So we've got x cubed minus x squared minus 2x plus 8. So let's go ahead and do our division here. So I need to ask myself, what number do I need to multiply x by to get x cubed? Well, that's going to be x squared. So I'm going to do x squared. Now I need to take this term and multiply by x squared to get x cubed, and this term and multiply by x squared to get negative x squared. And then remember, we're going to change the signs on these. And so what we end up getting here is we actually get 0 plus 0, and this number comes down, minus 2x. Great. So then because we have just a minus 2x here, what I'm going to do is I'm actually going to put in what number do I multiply x by to get negative 2x, and that's going to be a negative 2. So negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2. Now notice how I have this positive 2 here. I'm going to bring down this positive 8 as well, just so that I have a term to use. And so as we have that, we are going to then simplify this. Change our signs here, so this becomes a plus, this one becomes a minus, 2x plus, negative 2x plus 2x becomes a 0, 8 minus 2 becomes a positive 6, and this here is our remainder. So then our overall solution here is going to be our quotient, which was x squared minus 2, plus our remainder, which is 6, divided by our divisor, x minus 1. Awesome. Sometimes we'll have a divisor or a remainder, sometimes we won't. Anytime we have a remainder, we're going to put it over that divisor. Okay, let's take a look at one other example here. Let's take a look at this one here. So I'm going to write my divisor on the outside, x squared minus 3, and then divide it by our dividend. Now, notice here how this has an x cubed, an x squared, and then a 9. It doesn't have that x term. When we are doing this polynomial long division, we want to write in that 0x and that coefficient there, because then if we end up with that term, we can drop it down. So we've got x cubed plus 4x squared plus 0x plus 9. That way we just have something to pull down and we know what we're adding. So then let's go ahead and look. What number do I need to multiply x squared by to get negative x cubed? Well, that number is going to be a negative x. So x squared times negative x will be negative x cubed. Negative 3 times negative x will be a positive 3x. And notice how these ones are lined up here. I don't want to line those ones up. What I want to do is I want to line that positive 3x up over here with the other x. And so then what we want to do is we want to simplify these. So we're going to switch the signs on them. And negative x cubed plus x cubed is 0. Then this number is going to come down. So we've got 4x squared. 0 minus 3x is negative 3x. And then I'm also going to bring down my 9. Okay, then we're going to continue on here and ask ourselves the question, x squared times what number equals 4x squared? Well, that number is going to be 4. So we're going to have a plus 4 here. And x squared times 4 will give us 4x squared. And then negative 3 times 4 will give us a negative 12. And then what we're going to do is the exact same thing, switch our signs. This becomes a negative, this becomes a positive, and then we will drop down our things. So 4x squared minus 4x squared is 0. This number is going to come straight down, negative 3x, and 9 plus 12 is 21. Awesome. So now that we have those, we want to ask ourselves, is there a number I can multiply x squared by to get negative 3x? The answer is no, because notice how the degree on this polynomial here is a 1. It's just an x, while the degree on our divisor is a 2. Our remainder has to have a lower degree to be a remainder. Because this one has a lower degree, this whole thing is our remainder. So what that means is as we're writing out our quotient up here, or our answer to this, we end up getting that the negative x cubed plus 4x squared plus 9 divided by x squared minus 3 is actually going to be negative x plus 4 plus negative 3x plus 21 over x squared minus 3. Okay, so we end up with that fraction over there that has two polynomials, one on top and one on bottom. And we're just going to leave our remainder there as it is. So let's take a look at one last example here before we end our video. Now notice how this one has 3 terms. So we are going to do the same thing, x squared plus 3x plus 2. There's our divisor. Our dividend is 2x to the 4th plus 3x cubed. Notice we have no x squared here, so 0x squared plus 5x minus 1. Awesome. Okay, then we have to ask ourselves, what number do I multiply x squared by to get 2x to the 4th? Well, I need to multiply it by 2. And how many more x's do I need? 2. Perfect. So x squared times 2x to the 4th. 2x squared is 2x to the 4th. Then we need to multiply these two, so that's going to give us a 6x cubed. And these are going to give us a plus 4x squared. Now remember, we're going to change the sign on all of these. So this one's negative, this one's become negative, and this one's become negative. So these two cancel out here. Oh, and we get 0. 3 minus 6 gives us a negative 3x cubed. And 0 minus 4x squared gives us a negative 4x squared. And we're going to bring down our 5x. Okay, now we have to ask ourselves, x squared times what number gives us negative 3x cubed? Well, we have a 1 right here. So 1 times what number equals negative 3? Well, negative 3. And we have 2 x's, so we need 1 more x up here. So that'll give us our negative 3x cubed. Then we need to multiply everything else. So this will give us a negative 9x squared. And 2 times negative 3x will be negative 6x. Okay, so then we are going to continue on here. Don't forget to switch your signs. So plus, so this one becomes a plus, and a plus. And then we will simplify them. So this will simplify down into 0. Negative 4x squared plus 9x squared is positive 5x squared. Then 5x plus 6x is 11x. And then we're going to bring this negative 1 all the way down. Maybe. There we go. Ooh, a couple times. Okay, fantastic. Then one last time we need to ask ourselves, what number do I multiply 5x squared by to get 1x squared? Well, we need to multiply it by 5 here. And 1x squared times 5 is going to be 5x squared. And 3x times 5 is going to give us a 15x. And then lastly, we need to multiply 2 times 5, and that will give us 10. And then remember, we are subtracting, so we're going to switch the sign on all of these. So subtract, subtract, subtract. These ones all cancel, and we get 0. 11 minus 15x is negative 4x, and negative 1 minus 10 is negative 11. Okay, now notice how we have a polynomial here that has a lower degree than our divisor. So that means that this polynomial here is our remainder. So then we are going to write this out again. We're going to take our long quotient at the top. So this equals 2x squared minus 3x plus 5 plus, and then we have our remainder down here, which is negative 4x minus 11. Negative 4x minus 11, it's getting small here, over our whole divisor, which is x squared plus 3x plus 2. And that is how we do polynomial long division. So again, it's similar to regular long division. We just have to ask ourselves, what number do I multiply the first term of my divisor polynomial by to get the first term of my dividend polynomial part? And then we proceed to go on. Any remainders that we have left, we just put over the divisor in a fraction. And that is how you do polynomial long division. If you have any questions, feel free to reach out. Please check out the next video in which we discuss how we can do synthetic division using polynomials.